Hi Geometry, this is Unit 7, Lesson 5 notes, and I'm on page 819 of our workbook. So Unit 7, Lesson 5 is about circumscribed circles. That means circles on the outside of our triangle. So let's take a look at what we're doing in number 1. It says to construct the perpendicular bisector of segment AB. So it's been a while. That was September and October for us. And those of you at home may not have a compass. So why don't we sketch a perpendicular bisector of AB. Remember, to be perpendicular means it's going to form right angles, 90 degrees, and to be a bisector, it's going to go through the midpoint. So on AB, eyeball where the midpoint would be, and then construct a perpendicular line through that. So I'm very lightly going to try to draw what looks like a perpendicular line going through my midpoint. So let's do the same thing to sides CB and CA. So I'm going to get a different color. So CB, let's also put our midpoint approximately on there. Let's construct that line that appears to be perpendicular. Nice. And we're going to do that one more time for AC. So let me get a different color, put a dot at the midpoint of AC, and then construct what looks to be, or sketch what looks to be, a perpendicular line that goes through that midpoint. So if you and I did this accurately, our three lines should appear to intersect. So I'm going to mark that point and call it point D. So I want to mention a few things. Point D is where the perpendicular bisectors of the sides intersected. Point D has a name. D is called the circumcenter. And point D has something special. Point D is the center of the circle that circumscribes. The triangle. I'm going to just abbreviate that with a symbol. So what do I mean by circumscribes? Well, there's an important feature to D. One more bullet point, please. D is equidistant. That is one word, but it means equal distance to the vertices of the triangle. So let me draw that in with my yellow pencil. So let's connect D to A. Let's connect D to C. And let's connect D to B. Those are all the same. Those are the yellow lines I drew, and they're all equal distance. So let's put a tick mark in DC and DB and DA because those are all congruent distances. That's the radius of the circle that circumscribes the triangle we talked about in the third bullet point. So let's attempt to sketch a circle with that yellow radius and a center of D. It would go through all three vertices because it would have that yellow radius coming all the way around. I'm sure your circle looks so much better than mine. But this circle is on the outside of the triangle. Remember, to circumscribe means to be on the outside. And we call D the circumcenter. It's that center of that circle that circumscribes the triangle. And we created D because it was the intersection of the perpendicular bisectors. So let's discuss the location of our circumcenters. You could flip to page 823. Page 823. We have three diagrams that all show the circumcenter of a triangle. So let me grab my yellow pencil In the first triangle, that center is equal distance from the 3 vertices. That yellow distance is the radius. And so that circle goes through all 3 vertices. It circumscribes the triangle. It's on the outside of the triangle. So the same thing with the diagram 2. That distance from the center is the same. That's the radius of my circle. And the same thing for the third picture. These distances are the same from the center to the 3 vertices. So let's mark these the same. So these 3 triangles have a circumcenter in a different location. Let's discuss that. The triangle in the first diagram is an acute triangle. That means all the angles are less than 90 degrees. And the circumcenter is on the inside of the triangle. The second diagram, that's an obtuse triangle. You don't remember an obtuse triangle? That's got one angle greater than 90. This is my obtuse angle. He's larger than 90 degrees. And my circumcenter for an obtuse triangle is on the outside of the triangle. And the third triangle we're shown is a right triangle. Notice that the circumcenter is on the triangle. And in fact, not only is it on the triangle, but it is the midpoint of the hypotenuse. Those locations are important, and you're going to use them for fill-in-the-blank questions in our packet. So let's continue on to the next lesson to begin talking about an end center. This is page 829 of our book. And this is Unit 7, Lesson 6, a brief activity. So it reads, 2 angle bisectors have been constructed. So that means that this angle and this blue angle have to be equal. BD is an angle bisector. And then this little angle and this little angle at C also have to be equal to each other because EC is an angle bisector. It says sketch the segments that show the distance from G to each side of the triangle. So before I do that, let's take a look at where G is. This is the G is the intersection of the angle bisectors. So G has a name. G is the in center of my triangle. So it says in number 1 to sketch the distance from G to each side. So the distance from G to AC would be this short, straight distance between G and side AC. It'd be this short, straight, perpendicular distance. Let's do the same thing to BC. So eyeball where that short, straight, perpendicular distance might be. And do the same for AB. Notice where that short, straight, perpendicular distance might be. So it says, how do the distances from G to sides AB, that's the one on the left side, and BC, that's the one on the bottom, compare? They seem to be, or they appear to be the same. So the same distance. Let's take a look at 3. How do the distances from point G to the sides of AC, that's the top one, and BC, that's the bottom one, well, they also appear to be the same distance because we know from an earlier lesson that all the points on an angle bisector are equal distant to the sides. So this distance and this distance should be the same to the sides of this angle C. And the same thing was true in number 2. this distance and this distance should be the same to the sides of angle B. So it says, will the third angle bisector pass through G? Yes, it will. And because because point G is equal distance from the sides of that angle. So what do we do with these special sides? Let's put this first in our list. G is equal distant to the sides of the triangle. I'm going to put in parentheses, it's a perpendicular distance. This isn't a random distance. It's that red perpendicular distance. And this is the center of the inscribed circle. So let's put that on here. Let me get a different color, a yellow, and mark where your lines, your distances, your sides meet the triangle. And let's sketch in a little circle that touches the triangle at just those points. This is a sketch of my circle inscribed inside the circle. The radius is that distance to the sides of the triangle. And it's the end center, that is the center of the inscribed circle. And G, my end center, was made by the intersection of the angle bisectors. So let's take a quick look at another picture of an inscribed circle. This one is on page 839 of our book. And you can tell from this diagram that these distances to the sides from D are all the same. So I know D is equal distance to the sides. That's telling me that D is an end center. I can also see that the dotted lines are my 3 angle bisectors. That's a second reason D would be my end center. And also, D appears to be the center of my inscribed circle. So for all those reasons, I can see that D is the end center of that triangle. Let's make a chart to keep all of these important definitions and vocabulary straight. So on the page right next to this, on page 839, let's make a large, this is page 839. Let's make a large table. So this table is going to be 3 columns wide. The first column can be very narrow. It's going to be our titles. The next 2 columns, we're going to write our information, so we'll make those wider. The top row also can be very narrow. That's where we're going to put our titles. And then I need 4 more. So let's divide our table in half, and then divide each of those halves in half again. So our first column is where we're going to put all of our information that we've learned about a circumcenter. Our second column is where we're going to put all of the information we learned about our in-center. So the first thing we're going to write down is what our definition was. The second thing is we're going to talk about what important distance I know because of that. The third thing we're going to talk about is the location of my circumcenter and in-center. And the fourth thing, we're going to talk about the circle that they are the center for. So the circumcenter was the point where the perpendicular bisectors of the sides of the triangle intersect. The in-center was where the angle bisectors of the triangle intersected. So what important distance came from that? The circumcenter was equal distant to the vertices. I went through all the vertices, hence why the circle is going to be on the outside of the triangle. The end center was equidistant to the sides. It touched hence why the inscribed circle just touches the sides of my triangle. My location. There were 3 locations for the circumcenter. If it was an acute triangle, it was inside my triangle. If it was an obtuse triangle, it was outside my triangle. And if it was a right triangle, it was on my triangle. In fact, it was the midpoint. I'm going to abbreviate here. The midpoint of the hypotenuse. If it's the end center, it's the center of the circle inscribed. It's got to be inside my circle, always. What is the special circle associated with the circumcenter? Well, it is the circle that circumscribes. Oops, sorry, that's an S. The triangle. Remember, that's the one on the outside. And the end center is the center of the circle that is inscribed in the triangle. That's the one that's inside. Hopefully keeping all of these vocabulary and definitions in one place gives you a convenient place to look up your information. Thank you very much.